Hi, this is Elham Narang, EE267. This is final project presentation. My topic is facial emotion recognition and classification with CNN. Artificial intelligence and pattern recognition researchers commonly cite facial expression recognition is one of the most critical research areas in artificial intelligence and pattern recognition domain. This project will construct convolutional neural network to recognize facial expression. This study aimed to categorize each face photo into one of 7 different facial emotion group-based. There are trained CNN models with variety dips using grayscale photographs from the Kaggle pattern and used to train other CNN model. The model generated a graphic processing unit GPU to speed up the training process. There are 35,887 images that 80% of that is training set, 10% is test set, and 10% is validation test. And there are 7 different categories: angry, disgust, fear, happy, sad, surprise, neutral. I approached this project by specifying out clearly my primary purpose: classifying provided grayscale picture into one of that 7 labels. The picture classified text naturally leads me to a well-known convolution neural network. These are several random images from the data set. And these 3 are the main purpose of this project: angry, disgust, fear, happy, sad, surprise, neutral. You can see the mimic of the face and the expression. After researching around how CNN usually perform from the picture, I decided to start from 3 sequential convolution layer followed by max pooling layer that the commonly activation function that it's used ReLU. And for padding pattern, on the main use now is the same. After that, from the basic structure, I further added more and more convolutional layers with different feature captured. The features to be captured from convolution layer increases from 64 and 128 to 256. It is suggested that such a hierarchical structure with increasing layer nodes perform better from deep neural network. Finally, the convolution layer is first flattened and then go through 2 more dense layers to reach the output layer, in which softmax activation function is used for multi-class classification, that it's 7 classes in total. And I added my code here with all of the comments that it helps. For this project, I use one of the Kaggle codes for a reference, the accuracy that code could achieve was 0.7518, while with my CNN architecture model, I could increase the accuracy to 0.9703. This is 97% accuracy, and the error decreased to 0.0873. That is a negligible error. The result achievement is so impressive. This is the visualizing training performance, and the left side is model accuracy, that it's increased, and the right side is model loss or model error, that it's decreased. This is the confusion matrix to say the classes may confuse together, but as it shows the angry and disgust and fear with sad are the less, and the less is 93%. That is good, and the highest is 97 for happiness, and surprise, that it's high as well. For future work that I can recommend, changing the activation function. For this project, I use ReLU. Maybe sigmoid can increase the accuracy as well, or increasing the epochs, because for this project, I use only 20 epochs. Maybe higher epochs increase the accuracy, or trying different kernel, maybe 7 to 7, and adding more convolutional layer, because mine was 256, the highest, maybe 512 filter increase it. That's it. Thank you so much for your time.